we're solving two-step equations, it's very similar to solving one-step equations, but you're just going to have that additional step. And typically the first thing that you need to do is move the constant away from the side with the variable first, and then you'll solve it as a one-step equation. So you have to find the side that has the variable and get rid of the constant from that side. It's got to move over to the other side with the other constant. So in these examples here, I just want you to circle the constant that you would move first. So look on the side of equation that has the variable. So in this case, 4x minus 9 is that side with the variable. The constant here would be negative 9. So that's going to be the one that we would get rid of first. In our next one, we have 4 minus 5r equals 36. Negative 5r has our variable. The constant here would be positive 4, so that would be moved away first. In our third example, our variable is w. It's on this right side here. The constant on this side is positive 17. That would need to be moved away first in order for us to solve this two-step equation. So let's try some of these. Remember, our first step is to look for the side with the variable and get rid of the constant. So on this equation, we have 3x plus 1 equals 7, and 3x plus 1, our plus 1 is the constant. So I'm going to get rid of that. Now, in order to do that, I have to do the opposite of what's happening. So a positive 1, the opposite of that would be subtracting 1. Whenever you do one thing on one side of an equation, you need to do it on the other. So I'm going to subtract 1 on the other side as well. Now I need to combine like terms. So 3x comes down, positive 1 minus 1 becomes 0, so that disappears. On this side I have 7 minus 1, that's 6. So now my equation becomes 3x equals 6, and this is just the same as 3 times x equals 6. So what's happening to our variable? We're multiplying it by 3. The opposite of that would be to divide by 3. So on both sides of my equation, I'm going to divide by 3. 3 divided by 3 is 1. So I'm left with 1 times x on the left side here. And on this side, I have 6 divided by 3, which is just 2. 1 times x is x, so x equals 2. But before I can circle to say this is true, I want to go back and check my work. So my original equation was 3x plus 1 equals 7. I'm checking this for when x equals 2, so I have 3 times 2 plus 1 equals 7. Using GEMDAS, I do 3 times 2 is 6 plus 1 equals 7. 6 plus 1 is 7, and 7 does equal 7, so x equals 2 is correct. Now, on this next example, we have 3m minus 8 equals 17. First step, look for the side with the variable and get rid of the constant. So my constant this time is negative 8. It's on this side with 3m. So I have 3m minus 8. The opposite of minus 8 would be plus 8. So I add 8 to this side, and I add 8 to the other side. Now I combine like terms. 3m comes down, and negative 8 and positive 8 make 0, so they're gone. We bring down our equal sign, and 17 plus 8 equals 25. Now all I have to do is consider, okay, this is 3m, so that's 3 times m equals 25. So now what's happening to my variable? It's being multiplied by 3. So I'm going to divide by 3 on both sides. 3 divided by 3 is 1. 1 times m. 25 divided by 3, you could put that in the calculator and you would get 8.3 repeating, or that would be 8 and 1/3 as a mixed number, so I'm going to write it like that. And m equals 8 and 1/3 is our final answer. Now I can go back and check my work. I would have 3m minus 8 equals 17. 3 times my m value is 8 and 1/3 minus 8 equals 17. So 3 times 8 is 24, but 3 times 1/3 is 1, so this whole thing makes 25. Minus 8 is 17, so 25 minus 8, that is 17. This is a true statement, so m equals 8 and 1/3, or if you wanted to write it as 8.3 repeating, that would be an acceptable answer as well. Now trying a couple other examples. This time we have 6 minus 3x equals 21. So my side with the variable is over here, and the constant on this side is positive 6. So if I look to the left of this, There's not a sign here, but I'm going to assume that that's positive. So if you want to show that that's a plus 6, you can. So the opposite of plus 6 would be minus 6. So I'm going to subtract 6 from both sides. Positive 6 minus 6 becomes 0, so that goes away. Everything else that's left over here needs to come down, so that means I'm bringing down negative 3x. Don't forget the negative sign here. That equals 21 minus 6, which is 15. So this is just like saying negative 3 times x equals 15. So right now what's happening to x, we're multiplying it by negative 3, so I'm going to divide by negative 3 on both sides. When I do that, negative 3 divided by negative 3 is positive 1 times x equals 15 divided by 3, negative 5. 1 times x is just x, so x should equal negative 5. So if we test this out, our original equation was 6 minus 3x equals 21. So if I fill in our x, which is negative 5 here, I have 6 minus 3 times negative 5 equals 21. So 6 minus 3 times negative 5 is negative 15 equals 21. Remember that a negative or a subtraction, and when you're subtracting a negative, becomes a positive. So that becomes 6 plus 15, which is 21, and 21 equals 21. So that's a true statement. X equals negative 5 is correct. In our last example here, we have 1/3 y plus 5 equals 6. So our side with the variable is our left side this time. Our constant is positive 5, and I'm going to get rid of that first. So the opposite of plus 5 is minus 5, so I subtract 5 on both sides. When I do that, I bring down my 1/3 y, and my positive 5 minus 5 becomes 0, so they get crossed out. Equals 6 minus 5 is just 1. Now thinking back to what does this mean if my coefficient is a fraction? You have to multiply by the reciprocal. So the reciprocal of 1/3 is just 3 over 1. So I'm going to multiply by 3 over 1 on both sides. 3 times 1 is 3 over 1 times 3 is 3. So I have 3 over 3y, which equals, on this side I have 1 times 3, which is 3 over 1. So to continue to simplify, 3 divided by 3 is just 1, so I have 1y equals 3 divided by 1, which is 3. 1 times y is just y, so y needs to equal 3. If we go back and check our equation, we can make sure that y should equal 3. So if I plug in 3 where y is in this original equation, I get 1/3 times 3. If I have a third of 3, I have 1. So I add 5 to that. 1 plus 5 is 6, and 6 equals 6 is true. So y equals 3 is our correct answer here. So for these last examples, we have a word problem that we need to write an equation for. So I have a plumber charges $30 to come to a house and $25 an hour while fixing a leak. If the final bill for a visit was $105, how many hours was the plumber at the house? So how many hours? We don't know. H is going to equal hours for us here. That's going to be our variable. So if we reread this, it says the plumber is going to charge $30 and then $25 an hour. So just for the plumber to get to your house, he's going to charge you $30. And then for however many hours he spends there, each of those hours costs you $25. So I'm going to write that as $30 one-time fee plus the $25 per hour. That's 25 times the number of hours he's there. Now this family in this example had to pay $105 total. So I'm going to set that equal to 105. So here's my equation. Now I just have to solve for h to answer the question here. So I look for my side with the variable, and I get rid of my constant. So my constant in this case is positive 30. The opposite of plus 30 is minus 30. So on both sides I'm going to subtract 30 here. 30 minus 30 gets us 0. So we bring down positive 25h, which is just 25h. 105 minus 30 gets us 75. So right now I have 25 times h. The opposite of multiplication is division, so I'm going to divide by 25. When I do 25 divided by 25, that's 1, so 1 times h is just h. 75 divided by 25 is 3. So that means that the plumber spent 3 hours at the house. So if I multiply 3 times 25 and then add 30, that'll get me my total of $105 that we spent on the plumber. Now in example 2, it says Aiden's age is 6 years less than half of Maggie's age. Aiden's age is 4 years old. What is Maggie's age? So we don't know what Maggie's age is, so we're going to say that M equals Maggie. And we do know what Aiden's age is, so we're going to say his is 6 years less than half of her age. So half of her age would be half of M, and he's 6 years less than that. So we're going to take 6 away from whatever half her age is. And we know that he is 4. So we're going to set this whole thing equal to 4 here. Now in order to solve this equation, we have to look on the side with our variable and get rid of our constant. So in this case, our constant is negative 6. The opposite of that is positive 6, so I add 6 to both sides. 1/2 m comes down, and I have negative 6, positive 6. Those become 0, so they're gone. Equals 4 plus 6 is 10. Now right now I'm multiplying by 1/2, so I have a fraction as a coefficient, so I need to multiply by its reciprocal. So I multiply by 2 over 1 on both sides. 2 times 2 is 2, over 1 times 2 is 2, times m, equals 10 times 2 is 20 over 1. I continue to simplify here. I have 1 times m over, or equals 20 over 1, which is 20. So m equals 20 here. So that should mean that Maggie is 20 years old. And if we go back and check to make sure that makes sense, Aiden is 6 years less than half of her age. So half of her age would be 10. Take 6 away from that, you should get 4, and we know that Aiden is 4, so that's correct.